Hello, this is Trevor. Today we're working on a request smuggling lab in Portswigger's Web Security Academy. It is server-side pause-based request smuggling. So that was vulnerable to server-side pause-based server-side request smuggling. We need to smuggle a request to the backend admin panel at /admin, and then delete the user Carlos. We need to use Troop Intruder to solve the lab. And there's some other stuff. Okay, so let's open the lab, but then let's also open this pause-based desync so we can look that over. As we read through this, essentially what it means is that the front end and the back end timeout happens at a different time. So we load up all of this as a request, but only send this part and then wait to send this part. And what we're taking advantage of is the front end server sees this, waits for the rest. It doesn't come. It gets fed up and forwards this to the back end. The back end holds on to, responds to this, and then this poisons the next request. So the front end forwards the headers to the back end and continues to wait for the remaining requests. Sorry, I had it backwards. The back end times out and sends the response to this, while the front end, it hasn't timed out. And so it sends this as, because it's still as the body of the first message. The back end sees this as the start of the next request. And so this poisons the next request, and the back end responds. And then, so this will poison the second request. So if you remember with like the labs that we've done where we had authorization managed by the front end, and that if we could smuggle a request, we could get by that authorization and access the admin panel, which that's essentially what we're doing here. We're just taking advantage of the timeout difference between the front end and the back end. So the back end times out first with this request and then uses this as the start of the next request. Sweet. We need to be aware of that. Zero. And then this is how we're going to use it in Turbo Intruder. Sweet. Okay. Got that out of the way. Let's turn on burp. And let's do like we've done in the past. Just kind of request every page, everything on it so that we get a good idea of what's there. So I'm going to click every link, post a comment, view a few blogs, kind of do everything I think is necessary. So let's try Wiener Peter. Log in. No. Home. Click on the blog. Blah. 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 At blah. I need .com. Post. We get a not found. That's interesting. I don't know what that's about. Did our comment post? No. Okay. And I think that's it. So I think we've clicked on everything. Let's see what we've got. All right. Got a home. which is a 101, whatever. Oh, that was Mozilla. Sorry, this is the home, and we've got a 200. So should look. Isn't that? Didn't it note? It's been fixed in. Yeah. So this is the research server level redirects fixed in 2453. And we have 2452, so it's still vulnerable to server level redirects. All right, we've done that before. We know what to look for. So, like here, we send this to repeater and do like images. Boom. Send. We should get a 302. Yeah. Okay. So if that's the case, let's target this and let's delete all of this. We'll do a connection, keep alive, content length, I don't know, 50. Doesn't matter because we'll get it. We'll change that to post. And then we'll do a get / Trevor HTTP 1.1 x. So this should poison the next one. But remember, we need to do this in returner. Let's just send this so that content length gets updated. Come on. Come on. Come on. There we go. Let's send this to extensions, turbo intruder, send to intruder. All right. We need concurrent connections to be 1. Request, that shouldn't matter. Pipeline is false. We want to enqueue this. So we're going to do... we're going to do that engine.queue rec target.rec, and then those options that we saw in here, right here. So pause marker and pause timeout. Pause marker, pause timeout. If the request status does not equal 404, we don't want that. Let's just add everything to the table. 100 false. That was right? So let's go to 100 false. That's right. Okay. Let's attack. And remember, we have to wait for 60 seconds. And what it's doing, so it's sending, so what we expect, what we hope to see is that we get a 404 in the second response. We didn't configure the second response. Dang it. We want this, the follow-up. Ha. 1, 2, 3, 4. Okay. Sorry. Now we expect to get, let's change this. Get host. Now we expect to get a 404 on this follow-up. Okay. Crap. Okay. So we got to wait 60 seconds. If we get a 404, that means that we successfully poisoned that follow-up request. And then, if that's true, we should just need to get to change our original request to get /admin, because it won't matter what our follow-up gets. So this may be a fast one. Although we're going to have to make some changes to our Python stuff, because I don't know how to do the pause quite yet. All right. We get a 302. Oh, look at that. Ha! So we change this one to boom and attack. We should get a 404. And I'm going to have to wait 60 seconds to see if that's true. That's kind of annoying. I wonder how low we can get that. If I was, not doing one-offs, I would try to determine the lower bounds instead of waiting a minute every time, because that would suck. All right. We're almost done here, but what we can do is start looking at how we're going to implement this in Python. Should be any second. I said any second. There we go. There we go. We got the 404. Sweet. Okay. Yeah. So let's start implementing this in Python. We can /admin. Is it /admin? Well, let's run this while we start. Is it /admin or /admin/? Where are we? Here. It says /admin. Okay. Well, let's run that attack and see if it succeeds. In the meantime, let's start writing our script. So this is server-side pause-based request smuggling. Server-side pause-based request smuggling.py. All right, let's grab our template. Start out with that. And then we need to check how we're going to send it. So utils request smuggling. So this, that's all H2 stuff. Here we go. Send request. So this, we may be able to change this line to like send instead of send all, sleep, and then do send again. Let's pull this out and put it here and import everything we need, which is SSL socket, import socket, and then, so we need, instead of request text, what does request text look like? It's just the ASCII. So we need first request, second request, something like that. First request, second request, and then change this to send first request encode time.sleep 60 sock.send all, you think? Maybe. Okay. Let's import time. So we need to configure the first request and the second request. So let's use this create request text. What if we do request smuggling dot create request text and then body host path content length transfer encoding we want false, transfer encoding equals false. And do we want content length? Content length, yeah. If not content, yeah, that's what we want. We'll leave it to none. Transfer encoding to be false. So we just need to come up with the body, host, and path. Let's check on this. Ooh, this got a... Okay. Let's configure it to get admin and see if that worked any better. This was the request. So resources images is our path. Path equals this. Body will be something like this. Body equals except for we want /x/r/n, and we want it to get at least admin, maybe. Well, I think we've determined it's got to be admin / right? Oh, and how do I get the headers? Okay, post, host, and I need the keep alive header. I'm not going to use this because I need the keep alive header. Okay. So let's go here. Copy all of this. Exploit equals. I don't need triple quotes because I'm going to do the /r/n. But I am going to do an F somewhere at least. So I'm going to go to the end, a/r/n, host, blog.host, dt, end, d, end, there we go, x/r/n, connection keep alive, /r/n, content length. I want this content length to be calculated. And then /r/n/r/n, and then a body, right? Does that look reasonable? So here's the body. We need content length calculated. Calc CLN. Content length equals calc CLN. We need request smuggling. Request smuggling dot of body. Path. Sure. We can fill that in. No. It's going to be static. Okay. There's our exploit. Or this is... Oh, suck. I forgot. We need to split this up into two. Ah, dang it. Okay. So, we're going to do first request equals connection keep alive content length right here. Where does we want this to be part of the first one, right? And whoops, not part of this second request equals body. We're just going to forward it body. So then we do send request, first request, body, host, blog.host, port will be 443. Okay. Let's see how this did. Oh, crap. Unauthorized. Uh-oh. Only available to local users. Oh, crap. Oh, crap. How do we get past this? Only available to local users. So maybe instead of host, we do like 127. Alt configure. That would be host right here, right? Host. Because this is the one that gets added. That gets poisoned. Uh-oh. I don't know what exactly to do there. I should know, right? Because we've done it before. Okay, let's make sure this is all working. Send request. What does this return? Oh, it doesn't return anything. Does it? How do we get data from this? What the heck? We've never... And the whole time, we've never tried to get data from this request? What? Yeah. So we got to do like this sock receive. Return dot 4096 maybe. I have no idea. Print log.debug. Let's just start with this. Actually, that's a dumb thing because I'm never gonna wanna. I'm always gonna just change this. So why don't I just start it with resp equals this log.debug resp like that. And this is just a line too long. Yeah, error. So I'm going to ignore that like it doesn't exist. Did we get it? I think we got it. So, admin panel slash, oh, it's slash admin. What the heck? So we got close. But we need the slash admin. Okay, so let's halt configure. Not the slash admin slash. And let's do it here too. Will that screw it up? It shouldn't screw it up if we do run this one at the same time. Python. At least I don't think so. Don't know. Python server side -d and this. We need to log.info waiting 60 seconds for timeout. Just so we know what's going on. All right. Well, we're kind of waiting for everything. This one's almost done. So let's see how this worked. Don't give me a 302. Damn it! Why are you giving me a 302? And the last one, without the slash, said it was at slash admin. I don't know what to do there. Hopefully this one's almost done. So let's change. We know we want the so let's what do we want? Right now we've got the host in the first request. And first request here. The second request. What if we put the host in the second request? if we put the host in the second request, so like right here, host local host /r/n, maybe that'll work. Is that what I already did in this one? Found 200. But this is... Oh, yes, we did it. Oh, it's a post. Username, delete user. Oh, great. But we did it. However, we did it here. Configure. So we had the follow-up with the host, local host. Yep, that's what we wanted. So let's go here. Keep alive, timeout, content length, internal server error. Oh, great. Let's compare what we did here. So here's our follow-up. Oh, and we don't have a follow-up here. We send this, but then we don't send a follow-up. Follow-up equals, and I like calling it a chaser, equals that. And we just need to send this request. We can do it with requests, right? No, we can't. We have to use send requests. But we can use the original. But we still want to get the freaking response. I don't know how we went through this whole thing without receiving a single response from chaser. So to use this, request text host port. So this is the request text. And yeah. So we can do request smuggling dot, and we don't need it from the other one. We need it from this one. Dot, crap. Send request chaser. The host is going to be blog.host, and the port is 443. Okay. But we want to GCC. Let's do that. That'll print it. But hopefully we will eventually return it. And again, we don't care about the response from this one because we're not going to use it. We do care about the response from this one. Let's resp equals this. And then we'll return resp. Like that. I don't know. How else? So how did everything else? We got post resources images. Post resources images, HTTP1. We got the host. We got connection, keep alive. We got content length, which is calculated based on this. And that's calculated based on this, hopefully. Never checked that. But then we have the follow-up, which is host, localhost. Okay. Let's see what this comes back with. This is tricky. Tricky to get all this stuff right in doing it manually. And then we need to send a freaking post. Oh, crap. How do we can't see the response text anymore, which is lame. So instead of so we just need to change our body to a post. We have localhost here and localhost here. Is that right? No. We don't want it in here, because then we'll get duplicate header error. We just want it here. And we want /admin/ like that. Yeah. Has it been 60 seconds yet? I need to do log.info sending second part. Just so if there's some other timeout, like what if it's waiting for this? Like waiting to receive all 4096 bytes. Oh gosh. Let me look up 5p Chrome Python socket. How do I receive? Receive. What's receive message? Receive normal data up to buffer size. What's this one? Oh, this is the maximum size. Hey, we got something. Forbidden. Client error. Forbidden. 403. Well, that's weird. We did not get that in our tests in Burp. Okay. Slash. I made some changes. Let's try this again and see how it goes. And then we need to let's start working on the post. So the body is going to be a post /admin, or we don't know where yet. At least I don't remember. We'll just do like this. HTTP 1.1 /r/n x. We'll do it the same. And then all of this is the same, right? Send request. We need the chaser. And we need this. Oh, except for the body, we need, oh, suck. How do we get the... How do we get the arguments into the body? Because the next request attaches here, which is our chaser. Unless our chaser also has is also a post. We don't care where that posts to, as long as it doesn't get a throw server, redirect right away. It needs a content length of I don't know what yet. And it needs the content type of the www URL and coded whatever. Like this. This one. And then its body is going to be the information we need to post, right? That may work. .403 forbidden. So we're doing something wrong. Do I need to send... Why don't I send this one through the proxy? Okay, so let's... just to see what's going on. Because I need it to... I need to send it to there, but have a host of that. Okay. Let's figure out all the steps we need in using intruder, and then I'll try to figure out everything I need to do it in Python. So I'm going to redo this request. I'm going to take some images or copy and paste or whatever. And then I'll probably pause the video and come back once I've figured out how to do it in Python, because something's not... this should not get a 403 for the chaser blog host. So it sent the first one, waited 60 seconds, sent the second one. Maybe it's because it tried to do this instead of... Okay, so what do we need? Let's just copy Control-A-C. And throw this in Kate. Control V. So this is a form action / admin delete, and it has a CSRF. Oh, good. And then it just takes the username. All right. This is what worked. So we're queuing this, we're pausing there, and then we're sending the follow-up. Current connections 1. Let me copy both of these to Kate also, just so I have everything here. All right. All right. Yeah, I'm going to have to pause the video, try to figure out how to get as far as I've gotten in Turbo Intruder in Python. All right, I'll be back in a minute. Okay, so I got it working. It's actually the next day, but I did end up getting everything working, and my main issue was a problem calculating the content length body. I didn't have that right, but let me show you that it's working now. If I Python server side -d and then this, paste that, we can see it's right here. So we have to send the first request, which is this stuff, and then wait for 61 seconds. 60 seconds, I found it was hit or miss whether I got it. 61, it works every time. And then I send the second part, which is this, and then I receive, and I follow it up with just a normal GET request to the host, and then receive, and I return that response here, and then print it out. So what I expect to see here is the admin page, the same that we copied over from Burp right here, where it has the CSRF and the form we need to submit to. So we can start. Oh, here we go. There we go. There's the CSRF and the form. We can see that this one, right, wherever that right here, got the 302. Sweet. So it all worked. Let's let's extract the CSRF token equals utils.extract text. I'm pretty sure the pattern will be name. Let's put single quotes. Name equals CSRF space value equals this dot asterisk question mark and end with a double quote. And then we need to give it decode here. Okay. That should get us the CSRF token. Now we need to do the same thing, right? But have the target be a post to admin delete with the input required type name with the username equals to Carlos. Okay, so that is the body So this is now going to be a post to /admin/delete. I need to calculate. So let's name this second request and body second body equals. We're going to do CSRF equals CSRF token, and then ampersand Carlos equals, oh no, sorry, username equals Carlos. Like that. We need to calculate the content length of that. So we'll do the same that we did. Content length equals request smuggling.calc CLN of second body. Now, in this body, we've got the host. We need to add r/n content length, and we need to add a content type, and this needs to be the x-www-url encoded application / That's close. I don't think that's right, but let's check. Proxy, HTTP history. We want a post. Let's hurry up and make a comment. Blah, blah, blah at blah.com. Okay. XW form. I forgot the form, I think. Yep, form. Okay, so we have post URL, boom. We got host, localhost, content length is good, content type is good, application. Oh, we need to add the body to the end of this. A second body. Okay. Second request will be this. So now we need to do this. No. We need to do this. We need to calculate the length of this one. Length second request. I think this is right. And then this content length is the second request. The first request is the same as we had it before. And then we're going to, why is this still red? Content length second. Oh, because I don't have an F here. Okay. Then we're going to send the first request, second request to the blog host. All right, let's clean this one up a little bit. So I'm going to do parentheses, find a spot. We'll end it right here. Double quote, enter. Find another spot right here. And then this will go parenthesis there. Okay, so with that done, we don't need an F here. We need an F here and here. Write that. This is still red. Did I misspell something? Oh, instead of doing triple quotes, let's do single quotes there and there. And put back the parentheses. Okay, there we go. All right. Well, once this gets sent, we can log.debug resp.decode and blog.is solved. Okay, so just to double check what we just did, so this is all the get admin page, send request, this. Now, this is post delete form. So we got the CSRF token. We extracted that from the body of this first one. We defined the body of the second request to have that CSRF token and then username Carlos, and we got that from here where we got input CSRF, input username, and we filled that out. And I'm going to remove the triple quotes here too, just because. Once we had the body, we calculated the content length of that here. And then we built the second request using this body and this content length. So we got a post to admin delete, which is right there. Host, localhost, content length is what we just calculated. Content type, application, XWW form, URL encoded, and then carriage return line feed, carriage return line feed, the body, and then end it with 2. And then, so that made up the second request, which is essentially this whole line, right? Now that we had the second request, we can build the first request by calculating the length of all of this. Because remember, all of this is going in the body of the first request. So we calculated the length of the second request and then built the first request, which is the post to resources. That's our vulnerable endpoint with the host, a keep alive, and then the content length that we just calculated. And then we sent it. We sent the first request and the second request, which means that the first part, so these 2 lines, get sent. It waits 61 seconds. In that time frame, the back end will time out, and the front end will, after the back end times out, after the 61 seconds, the front end receives the body of of this first message and forwards it onto the back end. The back end sees it and expects it, or because it timed out the first one, it sees the second part and says, okay, this is a start of a new request, and responds to that, which then the front end forwards that response to us as the response for this first request. Anyway, I hope that makes sense. Let's give this a shot. What do you say? I think walking through it, and it looks right. So here goes nothing. 61 seconds. So we just talked through it all. So I guess if it works, it was right. There's nothing really I need to talk about here. I mean, it's all kind of the same stuff that we had. You send part of it, sleep, send the second part, and then I sent a third. I did use the same connection to send the third request, which is needed. So let's see how it goes. Fingers crossed. Okay, we got the first one. We didn't log the CSRF token, which is super lame. And, well, hopefully I don't have to run this again, but log.info CSRF token. And it would be good to have like a debug right here. Log.debug first request /r/n, and then first request, just so we can see it. Log.debug f second request. Uh-oh. Looks like we did not solve it. Dang it. Second request. Okay. Why did we not solve it? Oh, did I? What URL? Oh, stupid. Right here. I didn't do that. Well, at least that's what I think my problem is. All right, let's try this again. Now we need to wait another 2 minutes. Oh, this was a tough challenge, but I guess it's the last one last one as of now in request smuggling, so it should be more difficult. What else can I talk about? I don't know what else to talk about. Everything. We talked about everything. It's nothing too hidden. I can show you what I fixed in the in this library. Oh wait, okay. Post admin delete localhost. That looks right. This was the first one. Post resources, keep alive 175. I don't see nothing wrong with that. And we got the CSRF token. Boom. So it's on track. This is how, I don't know if this is the best, but I wanted to account for if I put in just /n or just /r, I don't remember which, whichever one my computer does normally, then it's going to replace that with /r/n. But it's not going to mess with if a /r/n already exists. Here we go. Yes! Boom! Lab is solved. Very cool. Yeah, and then we just encode it to binary, take the length, and turn it into a string and return that. That's it. I had some dumb stuff up here before, so we'll ignore it. But look, we solved it. Very cool. If you have any questions, definitely let me know. Otherwise, I'll see you in the next one. Thanks so much. Goodbye.